Hello everyone. So today is going to be our day 11 of DSA challenge that we took. And the question that we're going to solve today is sorry, repeating and missing number, right? Basically on Leetcode, I couldn't find the missing and repeated number variation. I could only find the missing number, right? So you can check. I have found the alternative on GFG. So on GFG or probably on GFG interview bit and coding ninja, the question with repeating and missing number is present, but on Leetcode it is only present as missing number. We're going to solve both of it in this video only. So the question states that a given array containing n distinct numbers in the range 0 to n, return the only number in the range that is missing from the array. Great. So let us paste this. This is the example that is given. Right. The ideal situation should look like this. Let me type it a little. So the ideal situation should look like 1, 2, 3, 4, 5, 6, 7, and 8, and 9, right? So basically, this array should ideally contain all the integers starting from 0 and n till n inclusive, right? Since this bracket is called for inclusive and this bracket is called for not inclusive. So you need to find out the missing number, right? What is the missing number here? If you check, 8 is missing in this array. 8 is missing in this array, right? 8 is missing in this array. So what you can do is how to solve this question, right? So let's start with the brute. Let's start with the uh, basic approach, basic naive approach. So what you can do is you can probably run a loop, right? You can run a for loop which starts from sorry, it starts from 0 and goes till n inclusive, right? Because you need to check, right? And you can initiate a counter variable, right? Counter which is equal to 0 right now. Great. You can run another for loop of, sorry, of j, which starts from 0 and goes till n minus 1, right? Goes till n minus 1. And you can check if, if array of I is is not equal, sorry, is equal to I, then you can increase your counter plus, right? You can increase your counter. And at the end of J loop, you can check if counter, or I can write it as well, if counter is equal to 0, then this is your return the missing number, since this is going to be your missing number, right? Because see, you are running your loop from 0 till n, okay, n inclusive. You are going from 0 to 9 in this example, for example, and you're initiating a counter, right? So a count will be equal to 0, right? J starts from 0 and goes to n minus 1. What is my I right now? I is going to be 0. J is also going to be 0. Great. So if array of I, what is array of I? Array of I is nothing but 9. Is it equal to Is it equal to 1? No. Sorry. Is it equal to 0? No. Then again, J loop runs. J1, J becomes 1. Is 1 equal? What is array of J? Array of 1, that is 6. Is 6 equal to 0? No. So basically, you will come till here and you will increase your counter. And at this position, your counter will be not equal to 0. So you again go back to I. Now I becomes 1, then this becomes 2, and blah, blah, blah. Till 9, it goes, right? And this also check every time for it. What is the time complexity for it? Very straightforward, right? You can obviously guess by now, because since we are running two loops, it is O of n squared, and space complexity is O of 1, because we did not use any space, extra space, right? The interviewer might not be happy with the solution and will ask you to optimize your time complexity. Now, what you can do is you can simply have a set, right? You can have a set or probably an array, right? You can have an array. Let me paste the example as well, right? You can have an array of 0, 1, 6, 7, and 8. 1, 0, 1, 2, 3, 4, 5, 6, 7, 8. And we can have a 9 as well. Since we need 9, we need including 0 and 9. So basically, we'll have an array of n plus 1, n plus 1 spaces, basically n plus, which can indicate n plus 1 elements. So you can traverse through this whole array. You can traverse through this whole array. What is array? Now you will start your for loop, right? I, which is starting from 0 and will go till n minus 1. Great. You will start from this position. What is array of I? 9. So you will put, you can initiate it by 0, right? Or you can put all the things by 0, right? You can fill all these elements by 0 with the function called array.fill, or you can do it manually. As soon as you encounter your I is here, what is it? It is 9. So you can increase the counter, you can initiate 1 there. Great. Then you come here, you is 6, it becomes 1, 2 becomes 1, 3 becomes 1, 5 becomes 1. Oh, sorry, where is 5? Oh, 4 also becomes 1 at this position. I'm sorry, I forgot it. Right? 7 becomes 1, right? 0 becomes 1, and 1 becomes 1. Now you will traverse through this array, and you will notice that only one position is left out, which is having 0, and which is 8, and you will return that because 8 is your missing number. Missing, right? What is the time complexity that we took? We took O of n for traversing this array plus O of n to finding out what which element is 0 here, which element is 0. So O of 2n almost, or you can type it as O of n only. But the space complexity is O of n again, or O of n, yeah, O of n. You can call it O of n only, O of n plus 1 probably, right? O of n plus 1. Since you took another array to initialize the hashing array, basically where you hashed your values and you incremented to 1 if the value is found. Again, the interview will ask you that I don't need you to use any extra space. You need to do it in constant space, linear time complexity, linear time complexity, right? How will you do it? How will you do it? That is something that we need to find out. And this is where our optimal solution comes. So we have discussed the nice solution. We have discussed the better solution. Now we come to our optimal solution, right? Now, what is your optimal solution? Great. So optimal solutions, there are two optimal solutions, right? One is using math and one is using XOR, math, and another is using XOR, bitwise operator XOR, which is this, right? You can read more about it on the internet. I may not be able to tell you this in this video particularly because it's a complex one and you need to understand various things, how XOR work, how bitwise operators work, and then you can probably find out how the solution is work, right? So we can solve it using math, right? Before even going further, let's discuss what is sum of all the sum of all first n integers, right? First n integers. So starting from 1 plus 2 plus 3 plus dot 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 till n. What is it? I hope you already know this formula. You can probably find it out using a for loop only, but why do you need a for loop when you already know a formula for it? It's n into n plus 1 whole divided by 2, right? So if you have to find the answer till 3, you will put 3 here into 4 by 2, which is nothing but 6. So 1 plus 2 plus 3 is nothing but 6, as you can already guess, right? So we would need an Sn, which is nothing but n into n plus 1 whole divided by 2. Great. Now what is f? I can initialize Sn as the first n natural number sum. I can initialize s as nothing but the sum of the integers that is given. So if these are the elements given, you can find out, you can initialize a variable called s, and this will be the sum of it. So if you sum it up, what is your Sn? First of all, it is nothing but 9 into 10 by 2, which is 45, right? And what is this? This is 1, 8, 13, 16, 18, 22, 28, and 37, right? 37. Now you can easily find out your missing, right? How can you easily find out your missing number? Can you please tell me? It is nothing but Sn, sorry, let me do it again, Sn minus S. Now what is Sn minus S? It will be nothing but 45 minus 37, and it will be 8. And is this your missing number? Yes, this is your missing number. Great. Let's quickly type out the formula for it, and then we can move on to the repeating. Right? This is more important. Missing number is very easy, and since you can notice already that this is an easy solution. Great. You can say that let Sn is nothing but n into n plus 1 whole divided by, right? And let required sum, or let S is equal to nums dot reduce. I hope you know how reduce works. It takes two accumulator and the value, the element, right? You can add accumulator plus element, and you can pass 0 as initial value, right? And return nothing but Sn minus S, right? And you can probably run it, and you will notice that this solution is working, and let's try to submit it, and this will probably get submitted. No need to worry about it. Great. It beats 99.53% users of JavaScript. That is something, right? That is something. Let's remove this. Let's quickly discuss the time complexity. Time complexity is nothing but um, to find out this f, you will run a loop. So O of n, right? And space complexity, since you did not use any extra space, it is O of 1. Let's quickly understand how we will find the repeating number. Now, if you go here, this is the question that is main, right? Uh, I do not find a very good example, so I'll just copy this, right? I'll just copy this. Uh, so what you can do is you can probably to understand your naive solution, right? To understand your naive solution, what you can do is you can run again. You can run a loop of for loop, and you can run it for I is equals to 0. Then in this question particularly, you will be given from your answer should be from 1 till n all inclusive, not from 0 till n. It was for Leetcode only. You can run your loop from I is equals to 1, not 0, and go till n inclusive, right? You can have a counter here, which is nothing but 0, and you can run a for loop of j, which will start from 0 and go till n minus 1, and you can check if array of I is equal to I, you can increase your count, right? You can increase your count, right? At this position, you will find, if, and you can obviously you can, what you can do is you can initialize that repeating. I will tilt it a little, don't worry. Let repeating is equals to -1, and missing is also equal to -1 for now, right? Let I should write it here, right? And if my count is equal to 0, then it is missing, obviously. Then it is missing is equals to I. If my count is greater than 1, then it is repeating. Repeating is equals to I. I hope you understood, right? Because if the number is not present, if the number is not present, so for example, if you start your I from I till and go till 3, your n is given as 3. If you start from here, for 1, the count will be 1. So it is there as we needed. You will go till 2 and you will find that count is 0. You will your missing will be I, that is 2. And when you go for 3, you will find that 3 is coming twice here, which is greater than 1, and you will notice that this is your repeating number only. What is the time complexity? Time complexity is nothing but O of n square, and space complexity is O of 1, since we are not using any space. Let's understand the better solution. Better solution, right? You can use again, you can again use hash map, right? Or maybe an array, right? Array will be nothing but n plus 1 value. So 0, 1, 2, 3, and 4. Since you need, or do you need it? I don't think so. I don't think so. You can take it till n only. You can have it as n values. Oh yeah, sorry. You need these values till n plus 1. Sorry, the size of it can be n plus 1, but the indexes should look like 0, 1, 2, 3, right? Let me erase this. Okay, no problem. I'll just do one thing. I'll just say, yeah, this is how it should look like, right? And you can run your loop from I is equals to 0 till n, right? What is your value of 0? It is 1. Then you can, since this will be filled with 0 initially, you can remove 0 and you can put 1 here. Your I becomes plus plus. It becomes now 1. Um, what is so no, you can probably run your I loop. I so let me write it here. Right, what we want. So for I is equal to 1 and goes till n, I is 1, right? I is 1. So first position, at first position, you can notice something. Or should we do that? Should we do that? We should not run it for I till, we can start it from 0 and we can run it till n minus 1. Great. Okay. And what we can do is we can find out what is this array of 0. Array 0 is 1. So you will let's put this as hash array. So of array of I, which is nothing but um what is hash array of I? It is 1. And what is hash array of 1, which is this? You can put it as um you can put it as you can increase your counter by plus plus. Basically, you can have a counter as 0, and you can plus counter, which will increase. I'll write the code. Don't worry, I'll write the code. Right? I can write the code, and so this is 1, and you go at this position. This is 3, then you increase it by 1. Again, this is 3, you increase it by 2. You will find out at this position, and then you will have to traverse this hash array, right? You will start from 1 and you will go till n. So at one position, this is 1, no problem. At this position, this is 0. So this will be your missing number. And if this is more than 1, this will be your um, this will be your repeated, right? So the time complexity will be nothing but O of n, and phase complexity will be O of n. Let's try to write this code. Great. Um, okay. What can we do to I am not sure if there is any function to initialize the values. So what you can do is you can let uh, hash array equals to this, right? Uh, what let's see, array dot fill md dot, right? You can do what you can do is what's the position? It takes values, it takes start, and it takes end. Okay. So if we see an example here, can't we? Okay, if I say this, starts from zero, then what will it return? It will return me this. Okay, so basically it needs a pre-filled array, and then it can, you know, mm, instantly changes all the elements with the starting array. It runs a modified array. Great. So basically it does not. So we'll have to have some values, or we can just not use fill. We can what you can do is you can run a for loop. Let I is equals to 0. I is less than equal to n. I plus plus. Is it great? 0, 1, 2, 3. Yeah, it is great. So hash array dot push is 0, right? And you can simply console log your hash array, and you will notice that your hash array should look like with it will have four values. For example, what is the problem here? Elements cannot be properties of same, not okay. Let me return something. Let me return 0, 0. No problem. Since it requires you to return something, so we can put that. Okay. Yeah, we can, our hash array looks like this. So it has three values for this particular example, right? Um, or we can do, uh, or we can do, let's see, we can do 1, 2, 3, and let's see what's the answer for this. You will notice that 0, 0, 0, yeah, four values. Great. So we are having our hash array as this. What we can do is we can again run a loop, right? We can again run a loop, and this, well, we'll start from I and we'll go till n minus 1. And if, uh, what you can do is you can simply say hash array of array of I equal to, you can initialize count 0, and here, right, you can initialize a count here, and you will say plus plus count. Should you do that? Should you do that? Okay, because every time I increases, 0 becomes this. Okay, what we can do is hash array or yeah, we can do plus is equals to 1. Great. I think this should give you the example. So again, if for let I is equals to 0, I is less than n, I plus plus, we'll start from 1, we'll go till equal to n, right? Because we are now traversing our hash array. So you can do, what you can do is, if hash array of I is equal to 0, then let repeating number equals to minus 1, and missing number also equals to minus 1. Great. If this is equal to 0, your missing number is found is I. If else if hash array of I is greater than 1, your repeating number is found is I. Great. What you can do is you need to return the repeating first. Repeating number, missing number. And let's try to run this code. I hope it should run. Yeah, it returns. And let's try to submit it. Great. Yeah, we have passed our solution. And so this is the time complexity and space complexity we have already discussed. Now let's come to the most optimal solution. And this is again going to use some of the math, right? But again, you can use XOR, and you can probably find out how you can use XOR and bitwise operators to solve this question. Great. We already know now that what is Sn? It is nothing but n into n plus 1 whole divided by 2, right? What is S? Is it is going to be sum of, matlab, basically you can say sum of array, right? Sum of array. Okay. Now, what you can do is, let's understand. Let's say my x is nothing but repeating, and y is nothing but what you can say. It should be okay. Let's initialize it later on. Let's initialize it later on, right? What was Sn minus s? What was Sn minus n? It is nothing but missing. This is the missing number, right? In the question that we solved in on Leetcode, this was s minus Sn minus s. Great. But here the numbers are there is one number that is repeating. So this solution fails. This solution fails. Great. Let's find out what is s minus Sn now. So if my example is this, right? What is my s? S is 3 plus 3 6 1 7 minus what is Sn 1 2 3, that is 6 plus 1. Okay. Um, Again, it is nothing. Since 1 plus 2 is 3, 3 6. Great. Mm, Great. This you can assume it as, sorry, you can assume it as x minus y, right? You can put it as condition 1, because you won't know, right? You won't know what exactly how this plus 1 came. Great. No problem. Now, you know that s to n, or s to n, what is s to n? Basically the square of all the integers. So 1 square plus 2 square plus dot 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 n square. So first n natural number square is nothing but s to n. What is the formula for it? You already know. So n into n plus 1 into 2n plus 1 whole divided by 6, right? Again, you can obviously find it out by uh, traversing the whole array. But why do you need it? Right? Why do you need it? When you already know the formula, right? So what is the s to n? S to n is nothing but x plus x. Okay, let's not use x plus y right now. So what is n? N is 3. So 3 into 3 plus 1, that is 4, into 6 plus 1, that is 7 by 6. This is goes by 2, goes by 2. This is nothing but 14, right? 1 plus 4 plus 9. Yeah, great. 14. 14 is the answer. Great. What is S here? S2. S2 will be nothing but squares of all these numbers, squares of the given array, right? So it will be 1 square plus 3 square plus 3 square. What is it? It is 9 plus 9 plus 1, that is 18. Is it 18? No, it is 19. Sorry. 1 plus 9 plus 9 is 19, right? What you can do is you can again write S2 minus S2n. What is it? It is 19, right? It is nothing but x square minus y square. It is equal to 19. Now you already have two equations, right? X minus y is 1. X square minus y square is 19, right? So you can obviously find out what is x and what is y. Great. So I can say that x square plus minus y square can be written as x plus y, and x minus y is equal to 19. And what is x plus y now? It is nothing but, and x minus y you already know it is 1. So it will be 19 again. 19 divided by 1, which is 19. Now you have two easy solutions, x minus y and x plus y. It is 19 and this is 1, right? You can add these solutions. So 2x is 20, x is equals to 10. Okay, this is x. Uh, I think I did a mistake here. I did a mistake here. Mm, let's understand again. Let's understand again. Okay, give me some time. I think guys, there was some mistake. I think I did a little mistake. So let me again write this. Okay, and we'll check again if I remove this, and let me copy this array. Right, let me copy this array and let me paste it here. Right, let me paste it here. This floating panel first. Great. So I have already written the code for you. Let me just try run it and then I'll explain to you side by side. Great. So now that we already know that what is our S2N and what is our SN, why is it so zoned out? Yeah, okay, let me select this and increase it a little, so at least you guys can see, right? Yeah. So now that you already know what your SN and S2N is, so we are now sure that S minus Sn is going to be our x minus 1 and our S2 minus S2n is x square minus y square. I think we have discussed till here. Great. So let's initialize our S is equals to 0 and S2 as 0. Now what is S? S is sum of all the integers that are given in the array, in the input array. And what is S2? It is the square of the it is the sum of the squares of the elements that are given in the input array. Great. So what is our Sn? Sn is n into n plus 1 by 2, which is n given 3. So n into n plus 1 will be 6 by 2, sorry. And S2n is going to be our n into, so 3 into n plus 1, that is 4, into 2n plus 1, that is 7 by 6. Again, it, it will be 14, right? It will be 14. So what is this part is done. And let's come here. Our S will be 1 plus 3 plus 3, that is 7, right? And S2 will be equal to 1 plus 9, that is 90. Great. We have find out. Now, what is the difference of sums? That is x minus y. It is what is it? It is minus 14, I guess. My What is s? S is 14 minus 6, right? And what is S2n? It is S2 minus S2n. S2 given is 14. And am I writing the right thing? Or I think I'm not. Oh, it is 7. Sorry, this is not 14. This is 7. This is 7. And this is 14 minus 19, right? So what is value 1? Value 1 will be difference of sum, right? What is difference of sum? It is nothing but x only. And what is val2? Now, why am I written it val2, right? So x minus y we already know is nothing but 6. But we need to somehow find out what is x plus y. Now, what is x plus y? It is x minus y is equal to difference of square, right? Or maybe you can write this thing, diff of, or let me type it here, right? X plus y into x minus y is nothing but difference of squares, which is x, which is s2 minus s2n, right? So x plus y, or you can write it as, you can say that this is x minus 12 y whole square. So if I write it like this is nothing but x plus y into x minus y, right? And you can say that x plus y is nothing but s2 minus s2n whole divided by x minus y. How, am I saying the right thing? Yes, I'm saying the right thing. Great. So val2 is nothing but x plus y, right? So now that we have that we have found out what is val1, val1 is 6. Yes. And what is val2? Val2 is difference of squares, that is 14 minus 19 is nothing but minus 5 divided by val1, which is, um, sorry, this is not 6, this is 1, right? So minus 5 by 1, right? Uh, or is it minus 1? I think it is, shouldn't it be s and minus s? Uh, why am I doing this mistake? What is the silly mistake that we are doing here? Difference of square is x square minus y square, right? Which is s. This is nothing but s2 minus s21. What is s2? It is 19. And what is our 1 plus? Oh, I'm really sorry. So it should be 1 into 1 in 1 plus 4, that is 5. 5 plus 9 is 14. Okay, there's no problem. This is 5, right? So if this is plus 5, this is, what is it then? Mm, 19 and 1. It should be, first of all, it should be plus 5, right? Not minus 5, because it's 19 minus 14. And this is 1. Great. Um, so 5 and 5 divided by val1. What is val1? Val1 is 1. So, so this is value 2. So what is x? X is nothing but val1 plus val2. What is val1 plus val2? 5 plus 6, that is 11, divided by 2. It should ideally be 5 slash 6 if you take the seal, if you take the floor and if you take the seal. Um, val2 is nothing, but this answer is not right. But somehow we are doing some mistake. We are doing some mistake. And what is that mistake that we need to find out? Right? That is something that we need to find out. Let me clear out all the things that are here. And let's start from the starting again. Why? What is that silly mistake that we are making? Great. Let's find out together, right? Let's find out together. We need to simply find out what is S minus Sn and what is S2 minus S2n. Fine. And our given array is this, right? Given array is this. Fine. What is S? Let's quickly find out what is S. S is 1 plus 3, that is 4. 4 plus 3, that is 7. What is Sn? What is Sn? It is nothing but n into n plus 1. So 1 plus 2, that is 3. 3 plus 3, that is 6. Right? So this is our this. And what is S2? It is 1 plus 9 plus 9. Uh, so 9 plus 9 is 18. So 19 minus 1 plus 4, that is 5. 5 plus 9, that is 14. Okay. At this position, we are right. Right? At till here, we are okay. We don't have to do anything. Great. Um, so what is difference of sum? It is nothing but 7 minus 6. That is 1. And what is S2 minus S21? It is 5. What is value 1? Value 1 is difference of sum only, that is 1. And what is value 2? Difference of square, that is 5 divided by 1. So it is again equal to 5. What is x? X is val 1 plus val 2. So 5 plus 1, 6 divided by 2. Great. Oh, this was the mistake that you were making. So 3 is the x and val y is nothing but What is val2? Val2 is 5. So 5 minus 3, that is nothing but 2. Finally, we have achieved it. So x is nothing but repeated and y is nothing but missing. Okay. Let's quickly reiterate what we did, right? We need to somehow find out what is x minus y and what is x plus y. Now, what is x? X is nothing but repeated and y is nothing but missing, right? We have initialized it somehow. And why are we doing it? We need to find out the s minus sn and s2 minus s2n. Now, what is Sn? It is n into n plus 1 by 2. This S2n is equal to n into n plus 1 plus 2n plus 1 by 6, right? These two values you can find out, and these two values also you can find out using loops. So, O of n is the time complexity for finding out this, and O of 1 will be finding out for this. Great. Now, what you can do is you can have difference of sum, which is nothing but s minus Sn, and diff of square, which is nothing but S2 minus S2n, right? So you have find out what is x minus y and you have found out what is x square minus y square. This you have found out, right? This you have already found. So this should be some value k, this will be value j, right? This will be some value. Now what is x square minus y square can be written as x plus y into x minus y, right? So this is all equal to j, and what is x plus y? This is nothing but j divided by k, right? And to find out what is x, you will just add add uh, these this thing. So it will be k plus j by k, and what is y? It is nothing but mm, j by k minus k plus j by k, which is nothing but k only. Are we doing any mistake? I don't think so. I mean, I hope you understood. I hope you understood like what am I trying to say, right? So you have already find out what is x plus 1, x plus y, and what is x minus y, and you just need to add all those situations, and then you can find out y, right? Mm, okay. Also, you need to divide by 2, right? X is nothing but k by 2 whole divided by 2, whole divided by 2. Yeah. So let's quickly write down what is our solution, right? This was our earlier solution. So let's remove this. Great. We need to find out our s minus sn, which is nothing but x minus y. We also need to find out what is s2 minus s2n, which will be nothing but x square minus y square. Great. So this is our what we require. Great. Mm, let's see. So what let s is equals to 0 and let s is equal s2 also equal to 0. Let Sn is equals to n into n plus 1 whole divided by 2. Let s to n is equals to n into n plus 1 into 2n plus 1 whole divided by 6. Great. Let's run a loop from I is equals to 0, I is less than n, I plus plus, right? S plus is equals to array of I, and S plus S Sn equals to array of I into array of I. So you have success calculating sum of input, calculating calculating sum of square of input, right? Great. Now let difference of sum is equals to nothing but S minus Sn. Great. Let difference of square is equal to S, S2 minus S2n. right? S2 minus S2n. Uh, this is not Sn, this should be S2. Sorry. Great. Now let val1, which is nothing but x minus y. I'll write it x minus y. Let val2 equal to mm, difference of square divided by val1. This is nothing but x plus y, right? To find out what is x, now let x is equals to mm, val1 plus val2 whole divided by 2, since I've already told you that if x plus y is equals to k, right? X minus y is equals to j. If you add both these solutions, so you get 2x is equals to k plus j, right? And what is x? X is nothing but k plus j divided by 2, right? This is what it is, and this is val1, this is val2. So this is this, and let y also equals to val2 minus x, and you just simply return x comma y. What is x? X is the repeating number and y is the missing number. Let's see if it is getting calculated. And you will see that expected output is correct. Let's try to submit it. And you will notice that this solution is also great. This solution is not passing. Does not work. Why it does not work? First case where my output is 2 comma 1. Okay. Why is it? Let's see what is my what is the problem, right? What is it repeating? My output is 2 1 and expected output is also 2 1. Why is it still not getting calculated then? Okay, sorry, there was some mistake with GFG. I don't know why. Yeah, great. It is solved. And we have already done this part. I hope you were able to understand. I know there were few here and there mistakes that I made, some calculation mistakes, and I hope you were able to solve all those things when you were watching the video. So thank you so much for joining in. I'll see you tomorrow with another video that is inversion of array and prerequisite is merge sort. So people who don't know what merge sort is, what we can do is we can first learn what is merge sort, or we'll see tomorrow. We'll see tomorrow. Great. So let's mark it as done. I don't think we need any notes here. We can do some of what you need, some of element and first n in integers, and you need sum of square of spelling of square correct, squares of element and first n square, right? And then you can use the math, right? Let's save it, delete it, and we have marked already are done. So thank you so much for joining in. I'll see you tomorrow with another video.